Hi, welcome back. We're moving to the point of deciding when we are rearranging atoms. We call that a chemical reaction. And to do that, we have defined what matter is. Last chapter, we were looking at this graphic, and we had organized it in a way of separating things that are pure from things that are mixtures. We're saying that pure things would be the atoms themselves, the elements, or bonded atoms in the form of compounds. These things are pure. And then over on the far right, we had mixtures, which is where we have these different compounds or elements in combination. What we want to do is move into the point of deciding when atoms are breaking bonds and making new bonds, which is the heart of chemistry. And to do that, we need to decide what are our indicators that chemical reaction has occurred. So we could talk about what's a physical property of the pure element itself. So what we have here is a graphic saying a physical property is just deciding what the characteristics are of that material. Now, it might not just be a pure element. It could be a compound. Here's water. So we know that water can be a liquid or it can be a vapor. So you have a tea kettle here, and as a liquid, the water molecules have weak bonds between themselves. It's called hydrogen bonds. Or you give it enough energy so that they become steam, gas molecules, but it's still H2O the whole time. Whereas a chemical property on the bottom is one in which we're talking about the reactivity of that element with other things. So iron reacts with oxygen and causes rust, which we know is always a problem. Corrosion is always a problem for bridges and buildings and cars and that sort of thing. When we talk about the characteristic properties of an element, I always think about the periodic table, because the periodic table organizes elements according to families. Columns on the periodic table organize compound or elements that have the same characteristics. So, for example, I'm going to take you down column 1. This video is coming from North Carolina School of Science and Math, which is an excellent school, and they've created a whole series of videos of laboratory experiments. I'm going to show you one about potassium K, element K here. And you will see on this a combination of a description of both the physical properties of the metal potassium, such as its shiny, silvery, soft metal, and its chemical properties, reactivity with water and air. So let's look at that video right now.
If we continue down the column to potassium, we see that the potassium metal is also stored under mineral oil to minimize its reaction with the oxygen in the air. If we remove a piece of potassium metal, we can see that the potassium is coated over with a gray coating of the oxide. As we continue down the column, group 1 metals get softer and softer. The potassium cuts very easily. As we cut through the metal, we expose the shiny metal surface underneath. The potassium is extremely soft. We can easily flatten out the potassium metal. It has a consistency of cream cheese. The potassium is a metal and is an excellent conductor of electricity. If we add a piece of potassium metal to water, we see that it reacts much more rapidly with the water than the sodium. As you go down the column, the ionization energy decreases and the metal reactivity increases. The reaction is very exothermic, and the hydrogen that's produced ignites. We can test for the formation of potassium hydroxide by adding phenolphthalein. The solution turns red-purple due to the formation of potassium hydroxide.
All right, so let's apply these ideas with a question. In this figure, you have liquid water and it's being vaporized into steam. Which diagram best represents the molecules in the steam? Is it A, B, or C? In A, you see the red is the oxygen and the white atoms are the hydrogen. And here we're saying that you still have H2O in the steam. In the B, we see two oxygen atoms joined together, which would be O2 gas and H2 gas. And in C, all of the atoms are separated. Which one do you think is correct for steam? I hope you picked A, where it's still H2O. We've just changed the state of the matter. We gave it enough energy to be separated from each other. However, we did not break bonds and form new compounds. We talk about chemical or physical change. In physical change, we're just changing appearance, but it's still the same material, just as we talked about boiling water. It's still water. Well, if we melt ice, it's still H2O in the solid form or the liquid form, but it's still H2O. But in a chemical change, we do rearrange atoms. So here's copper metal, which gets this characteristic patina, this pretty blue-green color as it reacts with oxygen. That's chemical reaction. We have CuO. Copper is Cu is the symbol, and CuO is the patina that forms. When we have chemical change, we are now looking at the heart of chemical reactions, and we spend a great portion of our year looking at chemical reactions. This is a really important box right here. Reactants are the materials that go in on the left, and products form on the right. In between, we have a chemical change that has occurred. This whole box is called a chemical reaction equation. We have some evidence of a chemical reaction. Now this is from Chapter 7, but we will apply this in our lab for this unit. These are some of our indications that the atoms are rearranging. Do we get a change in color? This is showing the baby spoons. Some of you might have a little brother or sister at home that you have a spoon like this in the house, but if it's warm, this turns from red to white. Do I get a solid that forms? This is a chromate liquid, and this has lead in it. When I pour this into here, I get this intense color, okay, and a solid that forms. That's a good indication that we've changed the atoms' arrangements. Thirdly, do we get a gas forming? If we get a gas forming, then something like H2 or CO2 is coming off and leaving behind a different arrangement of atoms. Here are 3 more indications of chemical change. If it gets hot, if it gets cold, if we get light emitted. So to summarize, when we do our lab in this unit, you're going to be asked, did a chemical reaction occur? Did the atoms rearrange? And the indicators of this would be color change, formation of a precipitate, which is what we call the solid, formation of a gas, whether it gets hot or cold, and if it gives off light or sound. Here's a word problem. See what you think. Which of these involves a chemical reaction? If ice melts, is that a chemical reaction? We would say no. That's a physical change. It's still water either way. B. An electric current passes through water, resulting in the formation of hydrogen gas, which is H2, and oxygen gas, O2. So we started off with H2O and we split it up into H2 and O2. This is a chemical change. Iron rusting. When iron rusts, it started off as iron, which is symbol Fe. When it rusts, it becomes Fe, my slow pen, Fe2O3. It changed. It reacted with O2 in the air and made rust. And then D. Bubbles form when a soda can is opened. When you have a can of soda, it's compressed CO2 gas, carbon dioxide, is pressurized into the water. And there's colorant and flavors added too. But when you open the can, you allow the CO2 gas to leave. But it's still CO2. We didn't change what it was, and left behind is still the water, the syrup, the flavorings, the colorants. So it's not a chemical change. This is a physical change. And we called this a chemical change. In our lab that we will do, called separation of sand and salt, we will need to separate a mixture. Well, there are different techniques that we'll use in the lab this year to separate mixtures. One of them is filtration. This is our setup for when we filter. You'll have the mixture in a flask like this. We're going to do sand and salt. We add water. The salt goes into the water. The sand does not dissolve. We pour it through a filter, and this has a paper in it. The solids stay behind in the paper, and the liquids pass through the paper into a beaker in which we catch the salt water, and then we'll be able to boil off the water and have salt left behind. And in that way, we separate sand and salt. Another thing we'll do is we'll use a centrifuge, which is a fast spinning device, and we'll have test tubes in that, and it forces all the solids to the bottom of the tube as it spins fast, and then we can do the technique of decanting off the liquid, leaving the solids behind on the bottom of the test tube. Another way that liquid mixtures would be separated is by boiling, and this is a separate setup for distillation. And the idea on distillation is that we have these liquids are mixed, but the compounds differ on boiling point, and so we'll slowly increase the temperature, and then they'll come off one at a time. The low boilers will come off first. They'll go into the gas phase, and then the gas will rise up through this neck, and it will condense right here and run off down this arm into a collecting vessel. And then we'll keep switching the vessels over on the right-hand side, separating out the compounds coming off by boiling point differences. Is the conservation of mass, the law of conservation of mass, and we are saying that's one of the laws of nature. There is no new matter. The atoms are rearranging, and so when we look at the left side of the chemical reaction, it's got to be equal mass to the right side. We've got to account for where all of the atoms went. Here's an example of that. This is reactants on the left, products on the right. If we say we have butane and we react it with oxygen and we form carbon dioxide and water, which is what we call combustion. This is the combustion of butane. Well, if we had 58 grams of butane at the beginning and 208 grams of oxygen, we have a total of 266 grams. This is our mass of reactants. It must equal our mass of products at the end. That's a law, and we operate within that law. That's it for this part of Chapter 3, and it will best be put into practice when we do our labs, separation of sand and salt, and the chemical and physical changes lab. You'll apply these ideas there and become much more comfortable with them. The final video for Chapter 3 is on energy. We'll see you there.